Hi, in today's lesson we're going to look at National 5 and finding the magnitude of a vector. We're going to be doing this without a calculator today, and part 1 is just looking at the skills that we need to be able to answer this type of question. Okay, so when we're working with magnitude vectors, it's important that we have prior knowledge in other subjects. You need to be confident working with Pythagoras' theorem. You need to know your square numbers really well. It's always helpful to know them up to 15 squared. You should already know them up to 12 squared. It's important that you understand the order of operations and that you can use BODMAS and BIDMAS. And it's also important that you've studied surds in the past and that you're comfortable with cancelling down surds into their simplest form. Okay, so when we're working with the magnitude of vectors, what we're talking about here is like the length of this line here. Okay, distance. Now, somebody's already kindly drawn in a triangle for us and labelled this side X, and up this way here they've labelled this bit Y. Okay, now this black line across here, I'm going to call it, I'm going to put a vector Z on it there. Okay, so hopefully you've done this with your teacher before, where to find the magnitude, okay, so remember the magnitude is the length of that line. To find the magnitude, you would be doing Pythagoras. We're finding the hypotenuse because the hypotenuse is opposite the right angle. Okay. One last thing to finish this off, okay, I haven't written down z squared equals x squared plus y squared, okay, so that means that we need to have a square root in there. Okay, so hopefully you've done that before. It's pretty similar to the distance formula that you'll have done with your teacher before as well, and that's how we do it when it's in 2 dimensions. Now this next one here, this question is a 3-dimensional question. So this time we have got x axis going that way and y axis going that way. Okay, now that looks a little bit different to what we would normally see when we've just got an x and a y, because this time going up the way we have got z there. Okay, now this one here, we've got a coordinate, an x, y, and a z coordinate there. Okay, this line here, okay, so it's got a wee arrow on it. Okay, I'm going to put a wee arrow in the middle. It's where the arrow normally is for your vector. It starts at O at the origin and it goes up to P, O to P. Okay, so the vector that runs from O to P, it could also just be called little p, and we would underline that when we are writing it with our pens and pencils. Now, this is what we call a position vector. Okay, the position vector is how you get from that O, the origin, where the x, y, and the z coordinate meet, where the axes meet rather. And to get from that point, we go along 2, and then along 3 on the y-axis, and then up 5 on the z-axis. Okay, so you can see it's very, very easy to turn the coordinate into what we call the position vector. Okay, now what we want to do is we want to find the length of this red line when we're finding the magnitude. Okay, so remember, magnitude, length of the line. Okay, so this time if I want to find the magnitude, okay, so notice that I'm putting these lines at either side of OP. These lines save us from having to write out the word magnitude. Okay, I could also write it like that with my little p. Okay, now again, we're going to use Pythagoras, but this time we've got 3 numbers. Okay, now remember, in the last slide we were doing add. Okay, so when we do it with 3 vectors, 3-dimensional vectors rather, we do 2 squared, 3 squared, and 5 squared, and then we do our working out to get our answer there. Okay, right, so we've got some examples here. And these are just, like I've said before, helping us to build up to being able to find the magnitude, which is that last one there. Okay, so when we do these, we need to think about Pythagoras, BODMAS. We need to think about BODMAS. So I'm going to tidy up what is underneath my square root. So I'm going to think about what 3 squared is, 3 times 3. And I'm going to think about what 4 squared is. Okay, again, I'm going to carry on with my tidying up under my square root sign. So I'll tidy that up into the square root of 25. And the answer to the square root of 25 is 5. Okay, now the next one. If you get given a negative number when you're working with your vector, be very, very careful to put a bracket around that negative number, okay? Now there's a reason for that, and it is because you have to think to yourself, I'm taking -3 and I'm squaring it, okay? So what's -3 times -3? A minus times a minus makes a positive. Okay, and 9 squared, 81. And that comes out as the square root of 90. Now I've just written the square numbers along the top there in green, because what I'm thinking for this one here is, can I simplify that third there? Okay, so I'm going to go up and I'm going to have a look. We don't tend to use 1, that doesn't help us to simplify it. Does 4 go into 90? 9 goes into 90, so the square root of 90 can be simplified a little bit. And just keep looking. No, 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 no. Okay, now I tend to half the 90 to 45, so I don't tend to look for anything bigger than 45. Okay, so at this point here I'm going to go, right, square number, 9 times 10. Okay, the square root of 9 is 3, and I don't know what the square root of 10 is. So that's my final answer for that one. Okay, next one again. Slightly bigger numbers. Again, you've got this bracket there. The bracket's especially important if we were using a calculator, but of course we're not today. A minus times a minus makes a plus. 6 squared is 36. Okay, again, the next one has got a minus. A minus times a minus makes a plus. 12 squared is 144. Okay, now if we add those together, okay, so I'm just tidying up my square root. Add those together, 180. Okay, so again, I'm going to go up to the top and have a think. Is there a square number? Yeah, there's definitely 9. Does 16 go into 180? 25, 36. I think 36 times 5 works. Let's try that. Does 36 times 5 at 180? 5 times 3 is 15, add the 3. Okay, so 36 times 5. Okay, the square root of 36 is 6, and the square root of 5, I don't know. I've got a couple more here. Okay, square root of 41. I don't think there's a square number goes in there. Remember, we don't bother with using the number 1. Okay, next one. Okay, so for this one, look and see if we've got a square number that goes into 40. There's one there straight away. Okay, so keep looking. Remember, half of 40 is 20, so I don't look any further on than 20. So it looks like this one's just 4. Oops. Square root of 4 is 2, and I don't know what the square root of 10 is. Okay, so this last one here, this is us on to one where we're thinking about what the magnitude would be. Okay, so I know that I'm working out the magnitude here because we've got these square brackets down the side there. Okay, so the magnitude of m, right, so the magnitude of m is equal to the square root, okay, and I'm going to use this 11 and this 5, 11 squared and 5 squared. And we get 146 there, so have a think. Do we have a square number that goes into 146? Okay, and the answer to that is no, there's not a square number that goes into 146. Okay, one more slide that we'll do together. This is building us up towards the three-dimensional ones, okay? So I'm just going to fill these in quickly. Again, just tidying up my square root. Is there a square number that goes into 26? Nope. Next one. Square root of 125, right. 25, how many 25s? 5 of them. The square root of 25 is 5, and I don't know what the square root of 5 is. Okay, so I've made a start in this next one. The largest square number that goes into 200 is 100. Okay, the square root of 100 is 10, and the square root of 2, I don't know. Okay, right, now, last one here, okay. I've written my vectors in a slightly different way this time. Vector v here, it's been written out, and just turn it back into a way that we would normally write it. 3i means 3 at the top, 2j, 2 in the middle, 4k, 4 at the end. Okay, I'll just move that over there. Okay, this one here, see how it's got I, J, K in alphabetical order? As long as it's in alphabetical order, you can just put the numbers like that. Okay. Again, it's got I, J, K, so just put the numbers in order, starting at the top and working your way down. So remember when we've got the square bits at either side of the letter there, remember we're just finding the distance, so we're going to be using Pythagoras. Okay, so we've got 3, 2 and 4 there. So for that one there, you get square root of 29 for your distance. 29 is a prime number, so we won't need to simplify that one. Okay, next one, again, when I am doing my magnitude, remember to put the square bits on either side of the letter there. Okay, so this time we're doing 6 squared, 5 squared and 8 squared, and remember we're adding them together. I think we've had 125 already. The question above had the same numbers. Okay, oh, so what I noticed there was that the question up there and the question down here, they had 6, 5 and 8, and I've just noticed the same thing for the next one as well. Okay, 6, 8 and 10, right? Because minus 6 squared is the same as 6 squared, 6, 10 and 8 is the same numbers, so we can get the same answer. Okay, so again, just make sure you put your square brackets on your V there. Not really brackets, just those straight lines there. Underline the V as well. Square it, square it, square it, and remember we're adding. So the working out, I haven't looked above, but the working out should have the same numbers in it as before. Yeah, that's good. So I'm going to get the square root of 200, square root of 100 times 2, and 10 root 2. So those last two, we'd actually already done the working out. Okay, so it just shows you how one bit of working out links to the other. So that when we're doing the magnitude, we are just using our Pythagoras work. And when we're doing the magnitude, it's always adding that you're going to have, because it's always the hypotenuse that we're working with when we're trying to find these distances for the magnitude. Okay, these are some questions for you to try. So if you hit pause now and work these ones out in your jotter and a piece of paper. Okay, and this is another page of questions for you to do as well. So again, hit pause and work these out in your jotter or on a piece of paper. Okay, there's your answer for the first one, just popped up. Okay, question number 2 actually had similar numbers in it, so you end up with the same answer for that one. Okay, there's your third one there. Okay, I've done the fourth one. I've started the fifth one as well. Just thinking about what the largest square number that goes into 116 might be. I know that 4 goes into 100 and 4 goes into 16, so I'll try that first. How many 4s in 100, and then how many 4s in 16? So 4 times 25 and 4 times 4. So that means it'll be 4 times 29. That's a prime number. Square root of 4 is 2, and I don't know what the square root of 29 is. Okay, remember for this one here, that when you've got your negative numbers, a negative times a negative makes a positive. Okay, if you've been checking these on your calculator, it's really important that on the calculator you do put those brackets in. Okay, now I've not said you can use your calculator, just said that you might have checked your work with a calculator. Okay, 208 for that one. Okay, so I knew that 4 went into 52, but I've just noticed that also 4 times 13 makes 52. These ones together, that makes 16, doesn't it? And the square root of 16 is 4. So my final answer will be 4 root 13. Okay, that was because really back at that stage there, I could have taken 16 out as the highest common factor, but I didn't notice it. So you can see it doesn't matter if you don't notice it there, as long as you kind of go, right, there's another square number that goes into that, and then you can finish it off from there. Okay, so that's the first one on the next slide, working out the magnitude of f. I hopefully noticed that this one's got similar numbers in it, so the answer to this one's actually going to end up being the same. Okay, so first two there have got the same thing. I can see the next two are going to be similar as well. Okay, so that's the third one done. Now, to get the working out for the fourth one, all I would have to do is put a minus sign in front of that 12, like that. We still have an add in there, it's just disappeared. Still have an add in there, but we've got a minus 12, but minus 12 squared still makes 144. So this one has got the same answer. Okay, and then we go into the ones where they're three-dimensional, so you've got Pythagoras in your 3 dimensions here. Okay, here's your next one there, and I can see that this one's going to have a similar answer to the next one as well. Okay, I've moved on to the last one now. You'll see that when I got to this point here, because it's all 4s, I've got 16 plus 16 plus 16. Now, they're all square numbers. 16's a square number, right? So I've actually chosen to rewrite this as 16 times 3. Okay, 16 plus 16 plus 16 is the same as 16 times 3, so that I can just go straight to do, and the square root of 16 is 4, and I don't know what the square root of 3 is. Okay, these two questions here, they couldn't be simplified. There wasn't a square number that went into those two numbers there. Okay, now that's all I wanted you to work on today, but the next 2 slides have got even more questions if you want to do some more practice. Okay, so you can stop the recording and have a go at these ones. And there's some 3-dimensional ones there that you can have a go at. And there's some more 3-dimensional ones that you can try there too.